All right, can you show my presentation, please? Good day, I'm Andrei Berekov. In this presentation, I'll talk about a hardware concept to protect against USB attacks. What's the essence? Let's assume we have a network of an organization where we have one segment physically isolated from the rest of the network, so it has no connection to it whatsoever. And I mean here by the internet, those segments that have access to that. Inside the isolated segment, we have computers, servers, and we need to deliver different files to them, antivirus updates, the updates for operating systems, and other files. The simplest way to run it is definitely to use USB devices like USB drives. We download the files on a USB drive, we bring it up, and we insert it in a USB port and upload the files. But there may be threats. Because this USB key can be exposed to various viruses, threats. A boot sector may be infected on it, containing malicious files. So the person who inserts the USB drive may be unaware of anything bad that he is risking of doing, but may damage the system with viruses. It's one classic threat. Then there may be devices that act like a USB drive. For example, a rubber duck with the embedded applications that run commands on behalf of a current user, and they may initiate these attacks. Or, for example, Teensy firmware. I spoke about it some time ago. Unlike a rubber duck, you can upload your own firmware to Teensy, and you can use your custom options. We also have bad USB devices that perform these attacks on USB controller. Apart from flash drives and things that act like them, consciously the users may smuggle different USB modems and different keys and dongles. So some fraudulent user may bring a dongle to the isolated segment and immediately turning this segment into a non-isolated one. And some suspicious content. There may be some legal files written on a USB file, but it's undesirable, so that these files are located in the isolated segment, like, for example, debuggers, etc. For example, there may be a user, a student who has smuggled some debugging tools to this sector, and then it may result in very unpleasant consequences. And the charges, we all know that the users may want to charge their devices, and such threats may arise. Like previously we said, there may be an LNK file with a malicious code running on it, like a warm Raspberry Robin that gets into this environment. How do you normally combat that? You can use the antivirus solution for that. It's the simplest solution. They may know which kind of antivirus solution is used here, and they may obfuscate their malicious code so that the antivirus lets it through. And we'd always have a delay in the updates of the antivirus databases. So if a If a fraudster uses a teraday, such viruses may get to the network from a dangerous device much earlier. There may be such policies, like, for example, prohibit the use these USB devices, and it's not always possible to do it quickly, so there's some fine-tuning required. DLP system is needed to eradicate such problems, but they're not intended for doing that. So you can give it a try, but that's not the best option. So the best option that would be recognized here, especially in the governmental institutions, is the physical eradication of USB ports. Like, for example, they glue them with tape, and sometimes system devices are put in a separate room, and only the peripherals like mouse and keyboard are available to users. So people cannot physically have access to a system block. But there may always be some human errors. People tend to make mistakes and pose threats. Of course, you can use IDS, but if you use this networking protection solutions in this closed environment, it's not always efficient. Apart from that, these networking solutions, they need updates and would have delays because of that. Some sandbox solutions may also be applied here, where we can use sandboxes, but sandboxes also need updates, and it would also cause a delay. So it's one of the disadvantages of this antiviral solution. As an alternative, I would be offering this hardware solution, an intermediary device between the PC and the USB device, which would read the files on USB drives, match the files for matching the policies, and emulate this device and connect it to the PC with only allowed files. So we have a PC, we have a USB, a hard USB drive, and this intermediary hardware device. On the flash drive, there may be some obfuscated viruses and the boot sector, but this device recognizes only FAT32. There is no boot sector running. Everything that had been created to automatically run would not run, because for this device it would be just a number of bytes that it would read and check without running. If we boot it from a device, this intermediary device only knows FAT32 file system. Nothing else will launch. And the modem, if we smuggle a modem and plug it to this device, it will not recognize it. If we plug in a phone for charging, you'll get your 5 volts, not the right amperage, but it will somehow charge it. But no malicious files will penetrate at all. So the implementation of this solution, the emulation of a flash drive which is formatted to FAT16. So we emulate this to FAT16, even if the drive is in FAT32. It is read-only, so data leakage is not possible. So it's a direct gateway for USB. But of course, we have all of the deficiencies of FAT16. We cannot use Cyrillic names, and the length of the file is 8 bytes plus 3 bytes for expansion. And the maximum size is only 4 gigabytes, so USB drives are not supported. As for other disadvantages, I should say that if we have Cyrillic in the names, this file will not read, but if it's a longer file than 8 by 3, it will be just shortened to 8 by 3, and it will still found, so it's not a problem. And the updates do not take too much space. 4 gigs, it's just an image of an operating system, but people would not normally download such things on USB drives. Hardware-wise, it's a sandwich from 2 circuit boards. The first one checks the files from the USB flash drive, verifies them, sends it to the second device, and emulates this flash drive on a PC and executes the allowed files. There are two such circuit boards. Just one USB port is required. Hardware-wise, no drivers are required, no additional power is required, just a regular USB port with 5 volts power. How do we filter the files? We handled the viruses, we handled bad USB drives, but how do we filter the files? And what policies do we use here? Simple policies can be used here by filtering by name or part of the name of the catalog, the path, the expansion. But these things are not that interesting for hackers. Hackers can easily bypass such limitations. So these policies are helpful for admins to put it in the catalog, to administer things and manage these things easier. But we can also get hash allowances, hash files, and we can analyze the first n bytes to define the type of a file. And if the file doesn't match any of such criteria, it will not be just shown on our emulated USB drive. How do we verify the type of a file for the first n bytes? We have heard some presentations regarding that topic. We use magic numbers. We define that for first n bytes. There are some combinations for n files, n bytes. Yesterday we had a presentation about how to forge a PDF file on a Python script, and that will be shown as PDF. To eradicate that, we can use the selection of the first bytes so that we are not limited by standards. So here is standard bytes, like it was shown on the first slide, and the user can on their own add the bytes if needed to extend the protection and make it more complicated for the fraudster. This is the editor of policies. First of all, we read here the most difficult policy, then it checks and verifies it versus the catalog and by name of the file. So if the file or the catalog matches the first criteria, all the other ones are not applied here, and it has the allowance. If it doesn't match with anything, it's not allowed. Then we keep these policies, and how do we send it to the device? It is sent in an encrypted file, which is written on a USB drive, and on the device we have jumpers. We have 64 options of putting the jumpers. We set the code, the device goes to the service mode, this file reads and decrypts it, and all of the policies are stored in the flash memory. Please speak closer to the microphone. I will. Thank you. Later, I would like to play a video to run my demo. Okay. If I speak into the microphone and if I keep it close, I can hear myself too loud. But it's necessary just for other guests. So I run this demo. Let's just watch this. We plug in the USB drive in a computer. We check the files on it. It looks like an ordinary USB drive. There are no boot sector viruses, but some suspicious files are there. exe files, executable files, hidden files. This is what the configurator looks like. Some files are given permission to. This file, catalog 77. This directory is given permission. and system 32, which is a hidden one, and we can't see it here, but still it's on the drive. We plug in the USB device, and the device has been plugged into the computer, and this is what it looks like. We have to debugging solutions, and here's our USB drive. We have this 77 folder, system 1, MU11 debug, and system 32, which is a hidden folder that we didn't see on the original source USB drive, but now we can see it because it stopped being hidden. Let me switch back to my slides. Anyway, that's the device I've described. Currently, it uses the STM circuit board. We have some issues with the hardware part because the hardware used there is foreign. It was made abroad. I'm done anyway. Thank you very much. Open for questions. Hello, thank you very much. There's a question. Can we upload these policies and rules remotely? Remotely. Well, it's a question of using the TCP stack. It allows TCP stack, but this current solution is a local one, but it can be updated to match these requirements as well. Question number 2, but what if the user bypasses this device somehow and plugs in the USB drive directly? But that's the matter of letting access. The fraudster will not get, or the user will not get access to the device itself, but they can somehow unawarely bring an infected device. But if the user can unplug such a device, of course, you cannot avoid it. But what about the USB indicator, PID? Can we just link only the particular physical device? We can harden it and tighten it to the device, so we can harden just one single USB drive and not allowed to plug in any other physical devices, other USB drives. So technically it's possible to do exactly. Thank you. Seems like that the one end device, we are ending yet another protection device. One computer, one device. But what if we scale it up with 1,000 PCs? Will you be plugging USB drives to 1,000 computers? Not really, because in a closed environment, we just have a few PCs. But I imagine a user comes up with a flash drive and to upload a file. But I don't think this is how it works in a closed environment. In a closed environment, it's all physically checked, what people have brought with them. Not every PC can have this USB drive installed. What about the settings? For one device, all these settings are run locally. They are not stored for other ones. For example, we have 15 devices and you need to adjust these settings 15 times separately. For each device, we have different settings currently, but there is no problem expanding it and scaling it up if there is a need, of course. Thank you. And one more question which we can't hear well. Now we can hear it. Is it compatible with any laptop, a Windows-based Android device, Linux-based device, anything? So personal computers with the USB connectors and laptops with USB connectors. It can be plugged in as a separate box. It's a separate black box, an intermediary device. It just physically looks like a black box, a small one. But which form factor will it have? It's just a matter of personal choice.